Hello everyone, welcome back to this channel. In the last video, we talked about the rate of reactions, and in this video, we will discuss what factors affect the rate of reactions and how they affect it. So let us begin. Okay, so the factors affecting the rate of reactions are as follows: temperature, pressure, surface area, concentration, and catalyst. So we will be discussing the four main things from here, which is temperature, pressure, surface area, and concentration. In my previous video, one of my previous video, I have talked about catalysts. So please make sure to watch that first. Okay, so what happens when we increase the temperature? It is simple. Increasing the temperature increases the kinetic energy of the particle. So this leads to more frequent and successful collision between the particles. And from one of my previous videos, I have talked about that to make a reaction occur, we need the correct energy and the correct orientation. If that two criteria are fulfilled, then the reaction must certainly occur. That's what we assume theoretically. So now we know that the temperature increases the kinetic energy of the particles. So this leads to more frequent and successful collisions. So that is one fulfilling criteria. Therefore, we say that there is a greater frequency of successful collision that leads to more products forming. So think it as this way: if there is more successful collision, so more reaction will occur, and if more reaction will occur, then more products will form as well. Another thing that we can say is that increasing the kinetic energy means that there is a greater energy in the molecules than the activation energy. That these molecules are able to overcome this activation energy barrier and form more products. So if our molecules can overcome this activation energy by having a greater energy than the activation energy, then more products will form and more reaction will occur. So here is a graph for you to see. This graph clearly states the effect of temperature. So firstly, this is called a Maxwell-Boltzmann distribution curve. It's really important that you understand this curve really well, as it may come in your exams. Now, in our y-axis, there is the fraction of molecules with energy, and in the x-axis, there is the kinetic energy of molecules, or also called the collision energy. And you see that the area under the curve gives us the total number of particles that are present here, and also there is mean energy of the molecules, which is indicated by a straight line. And there is also the activation energy, and just right after the activation energy, we see that it is the energy of molecules that is greater than the activation energy, and hence is able to overcome the barrier that is activation energy. All right, so now let's move on to the next graph. There are two temperatures given. Okay, so one is temperature 1, that is noted by the T1, and T2. Here, T2 is greater than T1. T2 is a greater temperature than T1. Now, what noticeable observations can we make from this graph? So, firstly, we see that the curve with T2 has a greater number of molecules with energy exceeding their activation energy. So yeah, as we said in the previous slide, with increasing temperature, the energy of the molecules increases. So this has a greater, and the graph is shifted slightly more after the activation energy. It is the height is relatively much wider, the gap is wider compared to the T1. So that indicates there is a greater number of molecules with energy higher than the activation energy.